So hey everyone. So yesterday we talked about Spark streaming, right? And we saw how word count program work. So what we did yesterday, we opened two terminal. Into one terminal, we were writing something into the console, and into the other terminal, we are reading the data and we are counting the number of words, right? Something like this. So we have this terminal in which we are writing some data, right? Sorry. And then we have one more terminal like this, in which we were reading the data, right? So now today let's do one more thing. Okay, before we jump there, let's see how we can write the same program what we wrote in a Scala shell, Spark shell. Can we write the same program into Scala ID? Let's see first thing, right? So what we need to go, we need to go for Scala ID here. And so whenever we want to write any program into Scala ID, right? So we need to do few things which I explained in a lot of detail in the previous sessions, but let me explain it further. So first of all, you guys need to create this Spark session, right? And into the Spark session, you may need to give some name to it, application name, master, and everything, right? And you can create your Spark context from your Spark session, right? And then from the Spark session, what we need to do, we need to create what we were doing yesterday into the Spark shell. From the Spark session, that's from SC, where we were creating streaming context, right? And this streaming context was acting as your entry point to the streaming context application, right? And then what we were doing at the end, we are in between, we are writing such program lines, and at the end we are starting the program. Okay, so let's do it one by one. So in fact, let's comment it. So what we did here, we created a Spark session. Then from the Spark session, we created the Spark context. Then from the Spark context, we created the Spark streaming context. And the Spark streaming context, we passed the Spark context and the window in the duration in which we need to create the D streams or RDDs, right? Forget about this for now, for time being. And then what we did, we were trying to read data from this console. So let me close this for a time being. So what we did here, that this is the data, right? And this is your this host. The host name is this one. In fact, let me show you the host name here. So Control C again. And when I say host name, so this is the host name, G02, right? Now, what we were doing yesterday, we were reading data from this host and we were running your Spark application into your master mode. Master mode is local. Now, what I'm doing today, we need to connect to this cluster, which is not into my local. I have connected to this IT Lab. And now I need to read data from this particular console, from any particular code, any particular port, right? So let's say if I want to start my NCCAT on port 6444, so what I did, I hit enter. It opened one port for me onto this particular host G02. And now what I need to do from my local Scala Spark streaming application, I need to connect to this port or this host and this port, right? And I'm using this socket text stream, right? Once this is done, we can clearly see here that this is read input stream D stream. Everything when we read from socket text stream will be a D stream, right? And the D streams will convert it into RDDs every 5 seconds. Since we are giving the windows interval as 5 seconds, then what we are doing, we are splitting that. Whatever we are passing into the console, we are splitting that based on the space. We are converting them into each word. We are mapping each word by 1, and then we are reducing each word, or we are counting each word by its key, right? And then we are printing it. Forget about this thing. Let's remove this for a time being. Okay. In fact, let me comment this part as well, because we didn't use this part yesterday, right? So let me comment this as well. And then what we did ssc.start, we start the application. Now let's try to run it. So it is trying to connect to the terminal and it is to read something, and let's see how it's working. Okay, let's open our terminal. Which one? This one? Yeah, let's open this terminal and write something. Hello. Okay, perfect. This is what I wanted to prove, right? It did anything, this application, our application, and it terminated automatically after one batch, right? After 10 seconds, after 5 seconds, it got terminated, right? Why? Because this is your local Scala ID application. So what we need to tell this application that, okay, please don't terminate by yourself, wait for my instruction, and to give this instruction to this Scala ID or this Spark streaming context, we need to use this line. That, okay, please don't terminate by yourself, await for the termination from the user. Okay, now let's run it again. So what we observe, that it got terminated automatically because we didn't give this line. So now we gave uncommented this line, await termination, and let's run it. So we already started one ANSI application to a port 644 onto this node, right? And let's see if this works for us. Okay, let's see. And now I hit 2 enters. Okay, so it just started working. So it created the first batch, right? And then I pressed 3 times enter. So it gave 3 spaces. Hello, I printed 1. Okay, now the second batch is empty, right? And now let's say we are typing hello, how are you? Hello, how are you here? Okay. So ideally, when I press enter, it should give me hello 2 times or 2 times, whatever, right? So it gave us. Now, one more thing. Let's say if I give hello again, so what it will do, it will help press this one time. What? And if I type hello in this way again, it will give me hello 1 time, only 1 time. But if I ask you guys that, okay, no, I want the number of words which have been written since I started the application. Can we do that? Right? So let me stop this and let me ask this question in other way. So we know that it is printing the word count for each batch, right? So let's go here. So when we go for Spark, this application, the application using Spark streaming. So what it was doing, it was creating one batch, right? Into this batch, if we give hello, then it's printing hello 1. After 5 seconds, if I write hello again, it create another batch and it again printed hello 1, right? But if I ask you, no, let's say this is 10, this is 5 seconds, this is 5 seconds, I want result like this, hello 2. It means I need to know what exactly happened in the previous batch and want to gather that information into my current batch, and then I wanted to print the result, right? So what it means, forget about Spark streaming. If I ask you, if I'm giving you 4 numbers, right? So let's say if I'm giving you 4, 2, 6, 8, and I'm asking you to add them. So you will say 4 plus 2, 6, 6 plus 6, 12, 12 plus 8, 20. So what you're doing, you are adding 2 numbers, you're keeping them somewhere, then you're adding the result to this number, you're keeping that somewhere, you're adding result to this number, and you're keeping the result, and you're giving that result to the output, right? So what it means, that even for people like you and me, we need to store the temporary result somewhere, right? And then we need to see whether, and just for a time being, one more thing, right? So 4, 2, 6, 8. This 4 plus 2 is 6, right? And then this 6 plus this is 12. This 12 plus 8 is 20. For example, if you forget this, then can you count this one? No. Why? Because you want to know what the previous state is. So what the point which I want to prove you here is that if we want to consider the information from the previous batch, then we need to maintain this state somewhere. We need to maintain this state somewhere. So we will call this information as state, right? State. So now, based on this information, we can say that Spark streaming works in 2 ways. The first way and the default way is stateless. Stateless. Operations like reduce by key, right? Map, flat map. These operations has nothing to do with the state, right? But if we want to have our application stateful, stateful means what? That please maintain some state, use some information or the metadata from the state, and then follow ahead. So stateful means 2 informations. The first is state metadata. And second is state value, right? State value into our cases 6 plus 2 plus 12 plus 8 means this particular intermediate result. So state value going to be 8 here, then it will be 6 to 12, 8, 20 here, then something like this. These are state values, right? And state metadata means your process is in which state. It's in running, it's completed, it's whatever, right? So let's jump into theory a bit. So what we are saying that there are 2 types of application. One is stateless. In stateless, every incoming record is independent of other records. There's no relationship between different records. Each record can be processed and persisted independently. Operations like map, filter, join, static data comes under static processing, right? When we go for stateful, it says processing of incoming record depends on the result of previously processed record, or we can say the previous batch. So we need to maintain the intermediate information between processing of different records. Every incoming record during processing may read or update this information. So what this line is saying, this particular line, that it will update your meta store or state store. We'll call it a state store, right? State store has 2 information, metadata and the state information. Okay, the intermediate information is called state. Operations like aggregating count record based on distinct key, deduplicating records are the example of the stateful processing, right? Now let's talk about this thing. If I ask you from the stream of data, only give me distinct data. For example, if the stream is coming like this, hello, this is first word, how are you? So these are distinct. So I want this application. Now if hello comes again, I don't want hello. If R comes again, I don't want R in my output. So ideally, what exactly we need to do in the duplicating, when we go for duplicating the results, we need to store this particular information somewhere, right? So that we can compare the incoming data with the previous state, right? So operations like finding the distinct key or deduplicating records, or maybe Windows key operation, which I'll explain later, will be stateful, right? So this is important. Now, what I was telling you guys, that state has 2 types of data. One is state of progress and the second is state of data. State of progress means which state your process is it in restarting, upgrade, task failures. And the state of data means what is the state of the data, like what's the intermediate data. It is the intermediate information derived from the data. or the data which is processed so far, right? This is processing need only stateful mode of processing. So it means whenever we go for stateful mode of processing, we need to rely on this state of data. Okay. Okay. Now this diagram is explaining the same thing in visual way. So this is our new data coming on, right? Now let's say we have the trigger point of 5 seconds and the events are generating 1 event per second. So it means every 5 seconds we will create a new RDD, right? So what we are doing, this is the 5th second. So what we did, we triggered our window here and we created a new RDD. Now, since we want to do some aggregation, which is stateful operation, we will be doing 2 things. Every time when we trigger a new RDD or new D stream, we will be updating the state store, obviously, and then we will be showing the result. Whenever we show the result, we will be updating the state store. So the temporary result will be go to state store after every processing or after every trigger. So when we see here, every time there are 2 rows coming from each trigger point. One into result table. Result table can be your console, can be your table, can be SDFS, can be anything. But 1 row or 1 input will always go to state store. And this particular trigger will use this state store to process further data, right? Now the question arises, obviously, when we want to deduplication, when we want to do some distinct keys, we want to go for stateful operation. But what is the practical application? One of the practical application is, let's say if you are logging into some website and we and the owner of the website want to maintain or understand your behavior in the real time. So whenever you want, like for example, you go to, let's say Amazon.com, right? You are on Amazon.com. And what you do, usually what you do, let's say you want to purchase a guitar. So what you are doing, you log into Amazon.com, you search guitar every time, and you go to some offer section. You didn't find the offer, and then you quit, right? So you are doing this for, let's say, for last 5 days, and you are not purchasing guitar. So what these guys can do that, okay, this particular person wants to purchase a guitar, but he's not finding any offer. That's why he's quitting. So they might give you 5% off, might. So this is, and how they are giving you 5% off based on your user behavior, right? So they have your user behavior. They will pull it on the real time from your state store. So every time when you're logging in, they will do something. So obviously they will keep this result, this click stream or whatever you want to call it, into some state store. When you're logging in again, they will pull this result, okay, what this guy did, and then they will do something like this. So this is how, state information is used in the real-time basis, right? Now, the question arises, let's say, if we want to count number of words in a stateful way, what we can do? Let's show it. Let's show here. So to count the number of words into stateless manner, we are using reduce by key. So we come to know that reduce by key is a stateless operation. It doesn't care about the previous batch or something. But if we want to count it into your stateful way, we have one operation called update state by key, right? As the name suggests, it will update the state